right, welcome everyone to Beyond Local Tools, deep dive into Model Context Protocol. My name is Maximilian Schellhorn. I'm a senior solutions architect working with AWS, and today I'm joined by James.
Hi, I'm James Ward. Work on agentic stuff at AWS.
Awesome. So James and we want to take you on a journey through the MCP landscape today. So we will start off looking into local MCP servers and its capabilities. We'll evolve that to remote MCP servers and explore the challenges along the way. How would you do hosting and scaling? And we will then look into MCP gateways, its use cases and capabilities. So speaking of capabilities, if we look back on how we built AI-based application like a year back or so, our applications were rather trivial in the sense that we were communicating with the LLM, but it has trained on a certain data set, so it has a cutoff date. So that means if you ask things about your current environment, like the weather here in that, for example, it would not be able to answer that. It would say, I do not have access to real-time weather data or your location. And it sometimes even gives you great recommendations. You could just look outside the window to get the current weather.
We don't have any windows here.
No, we don't.
Yeah. So it's wrong.
It's wrong. Yeah. So what do? So we started off now augmenting our LLM-based application. So we provided additional capabilities. We give them tools, we give them memory, and then the LLMs itself also evolved. So we have reasoning capabilities. And with all those capabilities together, we can now act and observe our environment. So if we go back to traditional tool calling, so prior to MCP, what happened now with the same example, if I ask what is the current weather in Berlin, we now also provide the tools to the model that it can use to fulfill the given task. So I'm not only sending the message, but I also send the list of tools. Here say get weather to and a good description that the LLM can figure out when to use that tool. So the LLM there says, okay, I cannot answer that with my knowledge that I have, but I can get the current weather by calling that tool. So it usually responds with a stop reason tool use and tells you, please use that tool now with that specific input parameter. Now, what the frameworks usually do is it's essentially just an if stop reason tool use. They then execute the local function, like a local Java function, for example, get weather, with that input argument, and then return back to the model, okay, I executed that tool, here's the result, content is sunny, and now with all the context of the previous messages and the tool result, the LLM is now able to say the weather in Berlin is currently sunny. Stop, reason, and turn, and then we know that we have to return the entire thing. Now, I told you this kind of get weather implementation is mostly, or used to be, a local implementation. So it's really you writing a get weather Java function and then passing that as the tools. So behind the scenes, you will probably make a REST API call to a weather API. You might have a get customer tool where you write SQL code that you can get records from the internal CRM database. And you might get tasks from an Asana API or get friends from a social media API. So why am I telling you all of this? Because you are basically responsible to integrate with every tool. And if you want to use those tools also in other projects, you would pretty much need to share those tools somehow between them. And also, the vendors who provide this functionality, they actually rely on you as an application builder, or if you build like Cloud Desktop or something, to integrate with their API so that LLMs can consume that. And this is where we now have MCP for. So for MCP, the idea is that we now only need to support a single protocol on the client side. And if the servers have an MCP capabilities, the vendors can provide and maintain those capabilities. And we should be able then to communicate with each other out of the box. So that means I can take any MCP host application, and they are using the dedicated clients like Cloud Desktop, Amazon QCLI, Kiro, VS Code, MCP Inspector, or any client that you write, and I then just can connect them to the MCP servers, like Company MCP server, Redder MCP server. And there are also MCP servers to control applications, for example, on your local desktop. So it feels like magic, but what happens under the hood is that we are just standardizing the way on how tool calling and also additional capabilities work. So under the hood, instead of doing this local call to our Java function, we're now doing a JSON RPC call with a predefined structure. And this is very different from when you're used to writing REST API with /resources and you do get, put, post, delete or something. This is really just a post, and the body itself contains, as you can see here, the method that we are calling. So this is the standard contract. So when the model now returns tool use, we are basically making that JSON RPC call. And there are a couple of initialize requests in between, but we will see that in a demo a little later. So we have learned about, we have now the client side that invokes those tools, and we have the server side who provides those capabilities. And now, speaking of the capabilities, we have tools, resources, and prompts. And we will learn now in the demo how they are used between the client and the server. James.
Yeah, so let's take a look at some code for how to actually do this. So I'm going to use a Spring AI application. It is based on the Java MCP SDK. And you can use that Java MCP SDK in whatever framework that you want. I'm just happening to use Spring AI because that's what I'm most familiar with. But let's start with just a basic tool annotation. So what I have is a method here called add, and it is annotated with this MCP tool, and then it has a description. And the description is important because that's what's going to indicate to the LLM inside the MCP client. We've got the MCP client, the agent, and the LLM all kind of hooked together. And this is what's going to trigger the LLM to say, okay, the user has asked me to do something. I can now use a tool to accomplish that. So that description is important. Let's go take a look at how this actually surfaces into a AI code assistant. And so for this, I'm going to use the QCLI, but obviously you have lots of options for your code assistants. They pretty much all support MCP at this point. And so first let me show you my MCP configuration. So what I'm doing in this case is I'm spinning up a local forked process to start up this MCP server. I did the boot jar to create my jar. I should have done the crawl native image and made this native, but we'll get to that in a future presentation. But there we go. That's how I start up my server for running locally. And so then when I run my code assistant queue, what's going to happen is it's going to initialize that server, and it takes a few seconds to initialize, but there we go. We got our server initialized there in 4 seconds. And now I can start to explore things within my code assistant from this MCP server. So the first thing is that I can just say /MCP, see that sure enough, I've got that one. And then I can say /tools. /tools is going to list all the tools that are available in this code assistant. You'll see that in my Spring AI MCP demo, I've got a number of tools available. So let's now try out that add tool that we added. Let's say add 2 and 5. So natural language, but then the LLM is going to look at that and say, oh, I've got a tool that can handle that through MCP. And so it's going to tell me, hey, do you want me to call the add tool with those parameters X and Y? And I'm going to say, yes, I could trust it. I don't really trust my own code, but maybe you trust yours. And there we go. Then we see that just like Max had shared, we then took the result of that tool call. We gave it back to the LLM. Then it was because all that came back from the tool call was the number 7. But then when we gave it back to the LLM's like, let me put that into a statement and say the result is 7. And so there we go. That's the agentic loop. And of course, we could call multiple tools, or the LLM could decide to call multiple tools in a loop to get to a particular state. In this case, we didn't need to. Okay, so that's my very basic use of MCP in a code assistant. Again, most code assistants support MCP today. So now let's go look at the protocol side of this a little more. So to see the protocol side of things, there's a tool that's called the MCP inspector. The MCP inspector allows us to inspect MCP and the actual protocol and things that are happening. And so again, I'm going to use the standard IO mode for my MCP server. I'm going to run java -jar, give it my jar, and then I'm going to hit connect. And when I hit connect, that should fork that process and then connect to the MCP server. And then use standard IO, standard in, standard out, to communicate with it. So the first message that we see is initialize. And with initialize, we see that we're getting the capabilities that this MCP server provides. And so that's the first kind of start to our message exchange with this MCP server. We also get a set level on logging called as well. But then we can start to explore the capabilities of MCP. The one that we saw before was a tool. So we can go into tools and say list tools. And then I can go to add. And now we see a UI that gets rendered word for being able to call my tools, so I can give it my X and Y and see my result there. And we can see in the history, we see the tool call. So again, this is just a JSON RPC message that got sent to my MCP server over standard IO, and it called the add tool, gave it the parameters, and then we get a progress token, which is a way to be able to send progress notifications. We'll talk about that in a little bit. Okay, so that's my very basic MCP server with a tool being used from, in this case, we saw 2 different clients. And the idea with MCP is obviously that you could take any MCP client. So that could be Claude.ai, that could be a code assistant, that could be your own agent that you build for your own uses. And so any of those things should be able to do these tool calls. Anything to add so far, Max?
No, all good.
Okay, all right, good. So let's go back and look at some more code. We're going to go through some of the other parts of the MCP protocol. So the next one is schemas. So in the first case, I returned an integer, not very exciting. What if you have structured data that you want to return? So of course you can do that. In this case, I've got very boring structured data. It's a multiply result and just has a field there for a result, and it's a record. And now I'm going to do something a little different with my MCP tool. I'm going to tell it to generate the output schema. So in MCP, by default, the input parameters are all schemaified, and so that's how the LLM knows what the parameters, when it needs to call a tool, what parameters are needed and are they required and what are their types. And so the input schemas are always there with MCP. The output schemas are optional. You may choose to turn them on if you want. And when we turn them on, then we're going to get that schema information in the tool descriptions. And so then your client, your MCP client, or your agent can then use those if it wants to. So then we've got some additional things to show here. We can also add annotations onto MCP tools, things to indicate to the client, the MCP client, is this a read-only operation or a destructive operation or an idempotent operation. And then we can also specify more metadata around the input parameters as well. So in the first example, I didn't give any descriptions. The LM still figured out, like, okay, that's an int, and it figured out where to put the numbers in. But in this case, I'm providing some additional description, which isn't very necessary, but then I can also say if these are required or not. Okay, so that's my multiply tool. Let's go look at that in the inspector so that we can see the schema parts of this. So I'm going to go to multiply, my multiply tool, give it some numbers, and then hit run tool. Or before I hit run tool, you'll see that, sure enough, it did see that there is an output schema for this object, and it's just has a field result. It's an integer. It's a format of int32. So not a very exciting schema, but could be more exciting. And then when I run the tool, we'll see that I get my structured output, and that's been validated to conform to that structure. Okay, so that's our output schemas. Anything to add on that one, Max?
No, looks good. What
Okay.
about notifications?
So for notifications, when we are in a tool call or other parts of MCP, we can get access to the exchange, which is essentially the channel that's been set up between the MCP client and the MCP server. And then we can do things on that channel like send notifications. So this is a server sending a notification down to the client. And we'll talk about the actual transport and how that works in a little bit. But in this case, our sub tool does a logging notification, and we just are going to send a log message. But let's go see what that looks like with sub. Let's come in here and say 10 minus 5, run that tool. And we run that, we get the result, obviously, but then we also see our logging notifications. So this went from server to the client, and we could put whatever we want into those logging notifications. But we can also do progress notifications. So maybe if you're in an AI code assistant and you've got some long-running process in your tool call, you want to actually be able to say, all right, I'm 10% of the way there, I'm 50% of the way there, and provide those ways for the client to then, the client would have to handle those progress notifications and display those in the UI in some way. But there is in MCP the ability to send these progress notifications through that exchange. We do have to use this progress token, which you saw in that tool call request. When the tool call request gets made, it passes in a progress token that then the client side can use to be able to correlate these messages to a given tool call. Okay, so that's our progress notifications. Anything on that?
We're doing great.
Okay, awesome. Okay, so next is resources. Resources in MCP are the way to essentially like get files, get database records, these like requests for resources. And so in MCP with the Java SDK, we can use this @MCP annotation. We can templatize our a URI to our resource. And so in this case, config:// and then we're going to templatize the key parameter. The name of this resource is configuration, and I give it a description. And this one, as Max said earlier, resources are not not invoked essentially by the LLM or the LLM deciding that it needs to invoke it. Instead, this is like the user in an agent deciding that they want to select a resource or use a resource. And so a little bit different initiator for resources. But so we've got, in this case, I'm just returning something easy and fake here for our MCP resource, and then we'll get into that completions here in a minute. But let's look at this in the inspector so we can see what this looks like. So if I go to resources, then let's clear out my resource templates and say list templates. We'll see there's my configuration template. And then I see I need to specify the key because that was parameterized. And so I can come in now and specify readme.md. You will see that it did a completion there for that README, and I'll show you how that works in a minute. But there we go. Let's select that and then hit read resource. That's going to make our JSON RPC call. We could see that in the history there on resources /read, and make that call, get the resources, and then we could do whatever we want in our MCP client. But let me show you how that completion works. So we've got another annotation here at MCP complete. We provide that URI, and then we get a prefix so that we can do some filtering, and that's how we can provide the completions that you saw. Okay, so that's what resources look like within MCP Inspector. We are going to see it in a little bit in a more useful UI, not just the debugging UI for how that looks in Claude.ai, for example.
Yeah, I think the important thing is that resources are really application controlled. So it's the application decides how to leverage those resources. You can actually build an application that leverages resources to build up a radic index, for example. Claude allows you to add, we will see later, resources to the user context. So it's really up to you, the app builder, to decide how you're leveraging those resources.
Yep. Awesome. Okay, so continuing on, the next thing that we have is prompts. And prompts are essentially a little key to a larger prompt. And so instead of the user having to like type in a bunch of stuff, you could just, if you have a prompt that you want to templatize, give to the user and allow them to invoke with a little key, you can do that. So I have a MCP prompt called greeting. It's going to greet the user. It's going to return hello and then an optional name for an argument. We can use MCP completions on those arguments. Let's go see how this one looks in Cube. So here what I can do is list my prompts, and I see that I've got one prompt greeting, and now I can call @greeting, and when I invoke that, you'll see that it used the default because I didn't specify an argument. So that prompt then got sent. So the prompt that I got back from the MCP server was just hello world. So then the agent sent that to the LLM, and then the LLM responded with, hello, how can I help you today? Great. And then, of course, we can specify parameters as well. And so like resources, these are application invoked, and the application decides how it wants to invoke them and what it wants to do with them. So that's our prompts for MCP. Then let's go on to a couple advanced features. Anything to add on prompts?
I think it's good to mention that sometimes if you're using an MCP server for the first time and you don't know which tools you have, how you would embed that in your flow, a good use cases for prompts would be to have like a description on how to actually use that MCP server, or have a predefined workflow that says, okay, I'm a travel booking assistant. I would recommend you to first find all the options, so you can really provide comprehensive prompt templates to give the user some way of idea how to interact with the MCP server.
It could be like a help prompt.
Yes, almost.
Yeah. Okay, so the next more advanced feature of MCP is called elicitation. This is a pretty new feature. All this stuff is evolving very rapidly. MCP is not even a year old yet. Elicitation was just added officially to the spec, I think, 2 months ago. And so elicitation is the ability for, given, let's say, a tool call, let's say you get into this tool call and you realize, oh, I actually need some additional data from the user. If you always need that additional data, you put it into a parameter. But if you sometimes need that additional data, then that becomes becomes an elicitation. This allows the MCP server to essentially trigger on the MCP client side in your agent asking the user for additional information. So we do this with schemas. There's a little bit better API that the Spring AI folks are working on for specifying the schema. I had to do it manually here, but here's my random triggering of an elicitation, just to show that we don't always want to do this, only sometimes. And we're going to create an elicitation request. So we're essentially asking the client to then fill in a random number. So we sometimes get a real random number. Sometimes we ask the user for their own random number. That's our silly use case here. But then this essentially blocks here at line 123, waiting for the user to actually complete that elicitation. And let me hit that. Okay, so that's how we program the elicitation. Let's go see what it looks like, at least in MCP Inspector. To do that, I've got a tool for random. Let's go run this, and I got the elicitation right off the bat, but there we go. It asked me for a random number. I can fill that elicitation in, and then we'll see that sure enough, I got that in the result of my tool call. If we run it again, hopefully we'll get we've got another. It's, random. Sometimes random is fun. Let's see if we can get, it just keeps, it really wants my input today. Thank you. Are we going to get a random? There we go, 23, actual random number. So that was the request without going into the elicitation block. Okay, so that's elicitation. Max, anything to add on that one?
No, you're doing great, James.
Awesome. Okay, last up for advanced features of MCP is sampling. Sampling is this kind of weird reverse thing for MCP, where usually your MCP server doesn't have access to an LLM. Certainly it can. You can do an agent as a tool, in which case your MCP server would be an agent and have access to an LLM. But usually MCP servers don't have access to an LLM. But what if it needs something from an LLM? Well, that's where we use sampling. Sampling allows us on a tool call, for instance, to get into the tool call. So we've made the request from the client to the server, but then the server says, okay, I actually need to run something through your LLM. Hey, client, you've got the LLM. Let me run this prompt through that, and then send me the result that you get back, and then I'm going to continue on my tool call. So we're going to make a sampling request. That's going to go over to usually to the LLM, get sampled, and then come back in here and complete that tool call. So let's just see what that one looks like in MCP Inspector. My tool for this one is Loud Joke. And so the idea with this is that I could ask the LLM for a joke, and then it's going to provide it. I'm not actually even using an LLM. In this case, I'm just in the inspector, which doesn't have an LLM. The inspector is just this debugging tool. So when I ran that, we'll see that I got a sampling request. So this would have come actually to our agent, and then the agent would do the sampling and hit approve, maybe ask the user for something if it wants to. And then we see that in my particular case, I uppercased what came back from the LLM, which I was the LLM in that case. So that's sampling, another advanced feature there of MCP. So that's our kind of quick run through of the features of MCP. This covers almost everything in the spec, right? Like it's not, it's new and it's pretty, doesn't have a whole lot to it yet. So that's just about everything there is in MCP except for authentication, which we'll get to in a little bit. One of the challenges with MCP is that you've got hundreds of different MCP client implementations. These are all your AI code assistants, your Claude.ai's, your ChatGPT. Lots of different things are MCP clients these days. And they all vary in terms of how much of what I just showed you they actually support. And so this gets tricky. They pretty much all support tools. That's kind of the standard. But only some of them support resources, and only some of them support prompts. And so the client implementations tend to lag the server capabilities. Hopefully at some point everything just catches up, or maybe the server just keeps evolving ahead of all the clients. Not sure how that will play out. But it's one of the things that you have to be aware of, is you may put a bunch of functionality into your MCP server and then realize that the clients that your users are using don't actually support those things. So that's just a tricky bit. If you are building your own agent, then you can certainly use these all the parts of MCP that you want. And so show you just real quick, this particular sample code that I have does have a client side using Spring AI and the MCP Java SDK. And this is, just showing you that I can make tool calls, I can fetch resources, I can handle logging events and progress events and elicitation requests and sampling requests. I can do all that in my own code, in my own agent that I'm building. So if you're building your own agent, then you don't have to worry too much about all the compatibility scalability challenges there. And then one other thing to note is that while I've been showing you Spring AI, you can use these same annotations outside of Spring. This particular example is using like at MCP tool, but then is just like spinning up its own web server and mounting the MCP stuff into that Jetty server, I think it is. And so you can use all the Java MCP SDK stuff on your own if you want to, or in Spring AI, or in Micronaut now has great support as well. So lots of different options for how you do that. Okay, that's our quick kind of run through on the protocol side of MCP. Anything to add on that?
No, that's great. I want to recap a bit of what we have just seen from the communication side. So we have seen that we are mostly running local MCP servers on standard I/O. So what happened is we had that configuration where we say, this is the instructions on how to start up the MCP server locally. So that can be Java, it can be NPX, can be Python. And then what happened is the host application then initiates the client, and you get this dedicated process to communicate over and via standard in and standard out. So if you would have another MCP server and another client, you would have another process where you communicate over standard in and standard out. So this is very good for a lot of use cases, right? So it's quite simple to build, it's fast because it's running locally, and you have access now to all the local files, the things that we've seen with the resources, for example, and also programs. I can control my local browser and other local applications. And stateful operations are relatively simple because I have that one-to-one relation between the client and the actual server. For the vendor itself, it's also quite convenient because they don't have any operational issue. They just ship, here's the local MCP server, please use it. However, there are a couple of challenges with that approach. So first of all, it's a quite developer-focused setup, right? So you need to have Java installed or Docker or NPX and all that kind of stuff, and you have this JSON configuration file. So it's a rather developer-heavy setup. So you probably not want an HR person to set up something like that. Anthropic is simplifying that, so they have desktop extension that you can drag, drop, and install local MCP servers, but still it remains a bit of a challenge. You might also be constrained by the resources that your local application has, obviously, and maintenance and updates become a challenge because you need to figure out when is there a new version of that MCP server, and you need to kind of pull that new version. And on another note, actually what a lot of local MCP servers did were something like that. So you have the local MCP server, and then it's just making a call to a remote API anyways. And now suddenly you were initializing that remote MCP server with API keys, and suddenly we have all the API keys flowing around in config files locally, right? So probably not the very best approach. And if the remote REST API is already like remote, why can't we just put the MCP server and also run it remotely? And this is what the Streamable HTTP transport allows us to do. So instead of having this local configuration of how to spin up the process, we just provide an URL, and then we hand that over to Claude Desktop, for example, and then the client will communicate with a remote MCP server on potentially another machine, but the protocol itself, like the communication, is still JSON RPC, so it still remains the same, but the transport essentially changes. And yeah, you might be wondering, we have HTTP and we're all quite familiar with HTTP, but have you heard of Streamable HTTP before? What does that mean, James?
Yeah, so what happened with the world of MCP was when it started, they essentially tried to model the standard I/O version of the transport over HTTP. And so what they did was they created two unidirectional channels of communication, like standard in and standard out. And so you do a post, an HTTP post to an endpoint, and then, well, first you start with the read side. So you do the HTTP get to a streamable HTTP, or sorry, to a SSE, server-side events endpoint. And then that just keeps the connection open and is able to be the way for the server to send messages to the client. But then you've got the post channel to send messages to the server. So it's like these two unidirectional channels. And it turned out that was actually hard to scale because then you have to deal with, okay, what if I have two servers and the post comes in on this one, but the person's connected on their server-side events channel on this other one? Just it became a challenge to scale and was pretty complex. So they created in MCP the new Streamable HTTP protocol, which allows you kind of two options. One, you can either just do a request and get the response with your like tool call, or you can do the server sent events method, which allows you to still have that thing that was like the standard I/O protocol, but over HTTP. So let's dive into what this looks like on the actual protocol and code side. So I have my application we were just looking at, my Spring Boot application. In the application properties, this is how we configure it for standard I/O, which is what we saw before. But if I want to now do Streamable HTTP, all I need to do is change the protocol. So I haven't changed it into the code. Just change the protocol to Streamable, and it's a sync server, and I have some parameters for port and immediate shutdown in here. So I can now start up this server locally. Of course, I could take this server and run it somewhere as well. It's just an HTTP server. And there we go. My server's now up and running on port 8080. Let's go back over to the inspector. And in inspector, I can now switch to using Streamable HTTP. I'm going to go to localhost 8080/MCP. And then let's just clear some logs so we can make sure that everything is going to work fresh here. Let's hit reconnect. When I hit reconnect, we'll see that it did initialize a new connection to that HTTP server. And so that did go over HTTP, not standard I/O. It didn't fork a process or anything. I forked the process in IntelliJ. And then we can list tools, and everything's going to work just like you saw with standard I/O in this case. So that Streamable HTTP is able to do essentially those push messages for elicitation. So we can go try to get an elicitation request here on random. There we go. Got it first try.
You're lucky with random.
I've been so lucky on this today. Yep. Really likes my randomness, which has been totally not random. Okay. So it all works, and that's how we switch the protocol over from standard I/O to Streamable HTTP. Okay, so that's our basic server up and running, accessible via HTTP. If I were to deploy that server somewhere on the cloud, whatever, then I could plug it into something like Cloud.ai, which has the ability to connect to remote MCP servers. So I'm going to show you what this looks like. I need to go fetch a URL here for the first MCP server I'm going to connect to. So this is a public MCP server for the AWS documentation. It's public, it's up on the cloud, and now I can come into Cloud.ai and I can say manage connectors, and I can come in and add a new custom connector. This will be for the AWS docs. And why would I want a MCP server for the AWS docs? Well, it turns out models have knowledge cutoffs, and the documentation for AWS gets updated every day. And so there may be new products that I want to be able to go put into my LLM and get access to. And so now with that MCP server, I can essentially like enhance, create an extension to Claude in this case with that additional information. So let's go do a new chat and make sure that that's all turned on. That's good. Here's a new service that has been announced since the knowledge cutoff of this model is something called Agent Core. So I can say summarize the AWS Agent Core runtime. So again, the LLM doesn't have any knowledge of this particular service because it's new since then. And so what's going to happen is it realizes, oh, I've got a tool that may allow me to help me do that. So I'm going to, allow it to use the AWS search documentation tool. And so that's making that remote MCP call. That's all happening on Cloud.ai, on that side of things. And then it's going to start reading some documentation that it got back in the search results. And then it should be able to learn everything that it needs to about this particular Agent Core runtime service and then give me the summary. So good example there of when a remote MCP server can really be a useful thing for plugged into whatever AI agent we have. This could be Cloud.ai or anywhere.
Awesome. But this is a public MCP server, and we probably have enterprise data that is behind like some form of security. So how would that look like?
Security is good. In this case, we didn't need any. This is all public information. Yeah. But let's look at an example where now we're going to connect to an MCP server which is secure. So Max actually built this one, and so I'm going to get the URL to his MCP server and come back into Cloud.ai, and let's go manage our connectors again. Let's go add a custom connector for travel. This is, I don't know, what is your MCP server doing?
Yeah, you can, essentially it's a B2B travel booking platform, so you can log in, it even has a form of tenancy, and then you can manage travel bookings, you can get your loyalty program info, you can get your travel policies for your company. So this is essentially, in a nutshell, what it's doing.
Sounds useful. Okay, but when I added this one, it says connect. And so that connect is there because I have not authenticated yet, and this particular MCP server requires authentication. So let's hit connect. And what it's going to then do is walk me through the three-legged auth loop where I need to then go to the login page. And I already created an account, so we can just sign in. And once I sign in, then we'll complete that three-legged auth. And now that MCP tool, your server, now has my authentication information, right?
Exactly. Yeah. So now you have a valid JWT token, and that allows you now to request your actually data that is behind the MCP server. So if you open, for example, the resources that we have now, this actually retrieves the resources actually are files stored on S3, which are now exposed as MCP resources. So you see here the travel policy. This is actually an S3 file, and this is just the files for that specific user, for example. So that's a way on how resources are actually look embedded in an application.
Nice. Yeah, so when we talked about resources, we showed them in Inspector, but this is a great use of using resources to, the user can come in and select resources from this MCP tool, and you can see all sorts of different ones that are there. Was that provided through completions, or is that, no, those aren't templatized?
No, this is a resource template that dynamically for the current user lists the resources that they have in their S3 bucket, for example.
Cool. And then I can use tools as well. So I can say something like, what are my loyalty? Or no, what do I say?
Yeah, loyalty points.
What are my loyalty points? So I always have a hard time spelling loyalty. Do I even need to spell right in the case of LLMs? What do you think? Is it going to trigger it?
I hope so.
That's a nice thing with demos and LLMs is I can totally mess it up, and it's like figures it out. All right, let's allow it. Okay, so that just called. Oh no, it failed.
Let's try it again.
Countered an issue. Let's get it to try again. Who am I?
Let's see.
What's the who am I?
Who am I gives the information about the current user and who's logged in. So you say it's triggered the who am I tool, and then you can run it again, the loyalty points.
Let's try it again. So rerun. I bet it's going to work this time, even with my typo. What do you think?
I hope
or do you think my typo is confusing?
Maybe. So
there we go.
There we go. Now it works. Okay, awesome.
Great. So that's now our MCP server with authentication. And yeah. Oop, wrong.
So,
did I cancel that?
That's fine.
I did. Let's go back here.
All right. So what we have just seen, and we want to dive a little bit deeper on what was actually in there for the authorization. So the authorization spec was updated in June. So there are a couple of things actually happening behind the scenes that you need to be aware of. So initially, we have seen this connect button, right? And this was because when we try to connect unauthenticated to the MCP server, we're actually getting a response 401 unauthorized, and we get an indication in the header www authenticate with a location on the protected resource metadata. And the protected resource metadata now contains the information on where are the authorization server for this resource server, actually. Now, the next thing, after you have retrieved that URL, you're getting the authorization server metadata from the authorization server to be able to know about all the auth and the token endpoints. And this is hosted behind the well-known OAuth authorization server or /OpenID configuration. And now with that information, the client can actually start the registration process. And this is a very important step. When we used to build applications and we were in control of our own clients, we were able to pre-register those clients in the authorization server. We have safe redirect URIs to actually get the proper authorization token. But now we have suddenly a new client coming up. We have a Cloud Desktop, then we have a VS Code. We have a lot of different clients that suddenly connect to our application that do not really have an identity or proper OAuth redirect URIs configured yet. So dynamic client registration is a way to dynamically now register this information. So it says, hi, I'm Claude. Those are my redirect URIs. Please register and give me a client ID. And only with that client ID, I am now able to get that JWT token, which I then can use to access the actual MCP server. So this whole dynamic client registration flow is needed if we want to connect any MCP client to any MCP server, right? They need to have a standard way of communicating with each other. So if you want to have full spec compliant, at the moment, this is the way to go. However, the challenge is there are not many authorization servers in IDP supporting dynamic client registration, right? So you either build like your custom solution around it, you probably do not want to mess around with that. So what happens is more and more clients are offering the way to actually pre-configure the client ID and client secret. So you would pre-register like in a developer portal or something like your Claude application client with the redirect URIs, you get the client ID, client secret in advance, and then you would only be able to communicate with that. And last but not least, this is mostly for external customer-facing MCP servers. But if you're building an internal application, like a private MCP server inside your network, maybe you want to use your traditional mechanisms, such as API keys. And you can do that if you're in control on the client and the server, right? But then not any client could probably connect to that. So what is needed then? The client needs a way to pass HTTP headers, for example, this API key, to the actual server. So you can definitely do that. Some of the clients are already supporting that now. So QCLI allows you to pass the actual headers, or you can obviously, as the knowledge server, can make that public. Now to recap, we see the remote MCP servers, they are now managed and maintained. So the provider really provides this capability. We have an authorization framework, they are easy to set up, and they are scalable, right? To some extent. We will get there in a second. So the challenges are, now you have this authorization framework, you have operational responsibilities. So you need to take care about a lot of those things. And obviously latency now becomes a problem as well. So speaking of scaling, James, we have seen how that worked with standard I/O right before. So how was that?
Yeah, so in the case of the standard I/O, it's great. Like we have a client, it forks a process, uses standard I/O to then communicate with that. And we could have another process, fork another instance, and pretty easy scaling, except for all the resources that you're using on your machine. So with local servers, easy. But once we make our server remote, which is, I think in a lot of cases, the ideal for these MCP servers, now we have hundreds, thousands of clients all talking to a single or more MCP servers. So then we have to deal with scaling. So there's some challenges with how we do that, because the usual way that we would do this is we would put a load balancer right in between our MCP client and our MCP server. Sounds like a good idea. Sounds easy. Then we can horizontally scale, add more MCP servers. But there's a challenge because the MCP protocol by default, what it does is it does sequencing of messages that need to be correlated. And so we send one message, the initialize, we send the next message, tool list, and it may not seem like those would have a problem going to different servers, but they actually do. So why do those have a problem going to different servers?
Yeah, so we have this stateful operations. So, and there was actually a blog post recently that David put together, the creator of MCP, which basically said the current implementations often need to remember things between requests. So you have seen that where remote MCPs established as SSE connection, for example. Sometimes for elicitation, we need to get the request and the response back to the same request ID. So there's some form of state embedded within those servers. And a lot of SDKs currently keep those session state in memory, right? So all your requests should go to the very same MCP server instance. Now, if you load balance across a lot of MCP servers, as we have seen, this is not guaranteed. There's a great talk from Sean Smith from Hugging Face on the last week's MCP Developer Summit that talks about a couple of those challenges, if you're interested in that. But with the current landscape of MCP SDKs out there, we would need to have a way to be able to route the requests to the same instance. And with the session ID, we would have an ability to do that. So we do an initialize, we get back a session ID, and with that session ID, we could technically do something like a sticky session to then route to the very same remote server instance. Now, we have been doing a lot of horizontal scaling over the last years to round robin across the server fleet, and now we're basically back to sticky sessions, which kind of defeats the purpose of scaling, because you might have imbalanced load now. You might have the most heavy users, like James and I, for example. We are constantly hitting remote server 1 because our sessions are tied there, obviously, right? The other challenge is not all load balancer support actually header-based routing. So this is the next challenge. And there are some, at least SDKs or even non-SDK implementations that are trying to externalize that session state, right? That you basically have like a caching layer or something else that all those instances couldn't get back that session. But still it requires a problem because it's embedded within the actual It's embedded within the actual transport.
There is one interesting thing I saw here. MCP, the specification, actually doesn't require a particular transport. It's just that like there's some suggestions on transport, and then there's the common SDKs usually support Streamable HTTP standard I/O. But you could technically put any transport into MCP. You just have to do that for client and server. And somebody built a SQS and SNS transport for MCP, which I'm sure would scale better. So not going to fit well in the ecosystem unless you add that to all of the SDKs out there. But yeah, there's opportunities to solve this in other ways too.
Exactly, and sometimes you do not even have control over this. So if you're used to function as a service environment, so AWS Lambda, you basically get your requests might be routed to hundreds or thousands of different micro VMs essentially. So you do not have that concept of a sticky session there. So what do you do? So the important thing is that a lot of the SDKs or frameworks provide running streamable HTTP in stateless mode. So then it doesn't matter where your request is hitting up because you're creating a new transport basically on every request. So in Spring AI, you can do that by setting the server protocol to stateless with that property, or in TypeScript, you can set the session ID generator to null. So you're not creating any sessions essentially, and now you can start round robin all those requests. However, you are losing out on a lot of the capabilities that we have shown, because you cannot, without a session ID, you cannot do sampling anymore that we have seen. So everything that is server initiated going back, that would require that initial SSE stream, would not work anymore. But this is the compromise that a lot of companies are currently taking. They just do stateless remote MCP servers to be able to round robin across the fleet. But it is a trade-off. And there is a discussion. Maybe we need to rethink our way of how we're thinking about compute. Maybe in the time of agents and MCP servers, we need more stateful communication and more stateful operations. So we might think about coming up with new compute primitives, for example. James.
Yeah, so at AWS, we have something called Agent Core Runtime, and it supports the ability to run MCP servers in the cloud. They're serverless, so they scale on demand. They're container-based, so that means we can take Spring AI MCP servers, Spring AI agents, and run them on Agent Core. And so, but how do we deal with that state in Agent Core? Well, we actually, for each session, each MCP session, we spin up a Firecracker micro VM, and that micro VM is then essentially this like sticky server that the user is going to be pinned to, but very low resource overhead for those Firecracker micro VMs. And so, yeah, Agent Core Runtime is one way to come up with that new compute primitive that can deal with this in another way, so we can still get that statefulness, all the good things of MCP, but without sacrificing, the horizontal scaling.
All right, and then we have, even if we have scalable remote MCP servers, we actually still have a bit of a challenge, because let's say I have hundreds of different remote MCP servers that I talk to. I might have hundreds of tools being exposed to my clients. So there's a couple of challenges. The LLM might be confused in having so many different options, right? If you have like 50, 100 tools, all the descriptions, the LLM might have a hard time figuring out what to do. And actually, this is a screenshot of where I connected to a couple of MCP servers, and basically 31% of my entire context window was just used up by all the different tool definitions that I have, right? So it also becomes
just the metadata.
Yes, so just the metadata around the tools, right? And last but not least, if you're just in your company and start like all the employees start suddenly connecting to random MCP servers, having their API keys all over the place, probably not something that you would want. And you can do that and solve that with MCP, because MCP allows you to have composability. So a server can also be a client at the same time, which allows you to build something like an MCP gateway. So you have a server, which is the single entry point for your enterprise, for example, and then you basically route to other MCP servers behind the scenes. And this allows you that, say, if I have a lot of tools behind the remote MCP servers, I can only expose the relevant tools, for example, to the actual client, and then save up on my context window. And those gateways also allow you to have something like searching tools. So instead of exposing all the tools, you could provide a search tool that says, actually search all the tools for that given task, and it returns me the list of all the tools that I now need to fulfill that task. Now, this also allows me to keep my context size and also the accuracy very precise on the actual client side. And even for authorization, so this is just an implementation example on Agent Core Gateway that provides the search tools, but there are a lot of open source solutions as well. There's MCP Context Forge, I think, from IBM. And if you watch the MCP Developer Summit from last week, there are like 10 talks just on MCP gateways. So you'll find a couple of options. But this is, for example, the gateway not only allows you to integrate with, in the future, also remote MCP servers, but also existing open API specs. So you can technically take an MCP gateway, proxy to an existing REST API, and expose those methods as tools. Or you can expose a Lambda function as a tool, and you get that serverless gateway layer before. And now, because I talked about the centralized governance, you're able to handle, for example, inbound auth. So how do you authenticate with that company MCP server now? You can integrate with your IDP, and then outbound, the gateway then manages in a secure token vault, for example, or via identity, API keys, takes care about refreshing the tokens that it needs to make the downstream calls to the other servers, and so on and so forth. So this is a quite good approach to think about that centralized layer. With that, we have covered a lot of things. We have seen local MCP servers, right? We have remote MCP servers, gateways, scaling. Are we missing out on anything?
I think we got it all.
All right, got it all. Awesome. So the outlook is, I want to share, there's a lot of proposals, requests on the MCP, on the Discord, and also on their GitHub channel. So the community is really doing a lot of effort in getting that protocol evolving and up to speed. We as AWS, we contribute a lot. And hopefully we could get you some new information today, and we're happy to take any question. We would ask you one thing: if you enjoyed the session somewhat, if you would just give us like 30 seconds and just provide your session feedback, that would be very lovely of you, because then we can improve our content, right? And also great to see your feedback in case you like that. Two things. We have the AWS MCP servers, which is a collection of a lot of AWS MCP servers that we provide. And we have also, last week, I have open sourced this remote MCP server playground, which has the Cognito authorization part. It's a custom built DCR, just so that you see how all those things would work behind the scenes in case you're interested. And with that, James, any famous last words?
Thank you for being here. Thanks for having us. Hope you learned something. Thank you.
Thank you.